Hi everybody and welcome. Today we're going to be starting some new content for Unit 2. So taking a look at some of the things we're going to see today, a pretty heavy definition day. It's kind of the case for geometry when we start a new unit. So switching up from doing some of the calculations that we were working on last week to more of just some definitions and some of the basics that are going to set us up for this unit. So today we're going to be looking at specifically different types of relationships with parallel lines and planes and skew lines and planes, and basically just looking at how things relate to each other when we put them into space. So we're going to have some words that we're going to be able to use to describe lines and planes when they are just occupying space. So to start off, one type of lines that we're going to see quite a bit this year are parallel lines. And these are coplanar lines that do not intersect. So key word here is they do actually have to share the same plane. So coplanar means they do lie in that same plane. So that is one caveat to parallel lines. So not only do they not intersect, but they're also on the same plane. So up until now, you've probably heard it described as, oh, they just don't touch. They never ever touch. But actually, they have to be on the same plane and not touch. So two conditions for parallel lines. And if you see them drawn on the state test, the way that you're going to know if they're parallel lines, and I'll draw this in red, is there's this little matching arrow symbol that's kind of like right in the middle of the line. So if you ever see this, it's kind of like an arrow directly in the center of a line. That indicates that wherever that symbol is matched elsewhere, that is a parallel line for it. So just something to note, if you see lines that look like they're parallel, so let's say that we have two lines over here, these look like they're not going to intersect. Well, unfortunately, because they don't have that little dash symbol, we can't say too much about them. So we can't confirm or deny that they are parallel lines unless we see that little symbol there. So just be careful. State test always out there to trick you, so don't assume anything unless it's specifically told. Next, we have skew lines. So these are lines that don't intersect and are not coplanar. So again, another example of things not going to intersect, but this time they're on different planes. So in red, I'm going to draw two different planes. So there's one little plane over here, living its best life. And then here's a second little plane way over in the distance somewhere, kind of below it, off to the side. And in black, we'll say we have line A. And in also black, we'll have line B. And if you look at these, they look like they're going toward each other, except if we're looking at our plane, we'll call it plane capital A and plane capital B. If we look at these planes, because they're so far below each other, there's no way for them to ever possibly touch. So even though they might pass below or under or beside, they're never actually going to cross because they're not in the same plane. So that's what skew means, is that even though they don't intersect, this is an example, they're not parallel because they're not in the same plane, but still, they never touch. They don't intersect. Our next word here is jumping from lines to planes, parallel planes. So these are, put simply, planes that do not intersect. So my favorite analogy for planes is always just like a piece of paper. So it's like if you take that one piece of paper and you just extend it off infinitely in all different directions. So if we're looking at this as like that piece of paper as that plane, we do have to assume that it is extended just basically everywhere. It'd be like a piece of paper that covered the entire Earth just in all directions, but that really, really thin line that just goes completely straight in all directions. So if, again, we have plane A, a parallel plane B, we'd have to be really careful when we draw this because it can't be like tilted up. It can never actually go through plane A. So parallel planes would be like directly beneath or directly on top of each other, pointed in the same direction. So it's not like one's pointed up and one's pointed down. Like they exactly mirror each other in every single way. They're just a little bit above or a little bit below. So A and B here would be parallel planes. But if we had something like this as a second example, and then like this plane is like angled this way, you can see that it's going to intersect. If it's kind of like tilted, angled up, it's going to eventually cross through plane A when it's extended in that direction. So if we had like plane C here, that one would not be a parallel plane because it's, like I said, not matching in every single way. It's kind of angled up towards plane A. So not parallel on the right side here, but it is parallel on the left side. Final word for today, and this is where we're going to see a lot of our practice questions come from, something called a transversal. So a transversal is a line that intersects two or more, so let's write 2 plus, so it could be 3, it could be 7, as long as it's at least 2, 2 or more coplanar lines at 2 different points. So if we have, let's say, just go back to just any 2 lines here, and we'll say that they're on the same plane. The line that goes through them, so in red here, this red line is what's intersecting multiple lines. That's called the transversal. So the line itself must cross multiple other lines, at least 2. More than 2 is totally fine, but at least 2 other lines it does have to go through. So if we label these, we'll call it line A, line B, and line C. C is the only line that actually touches 2 other lines. A only intersects with C, it does not touch B. And B only intersects with C as well. In this diagram, it does not touch A. So because of that, C is our transversal here. So with transversals, there is a whole host of relationships that are created specifically when we see some parallel lines. So that's what we're going to be taking a look at here in just a moment, is some of our vocab words for how these things work out. So transversal P, so we'll take a look at this here. So transversal P intersects line Q, and it also intersects line R. And they give us 1, 2, 3, 4, 5, 6, 7, 8 different angles. So based off of this green transversal forms a whole bunch of different vocab words now that we have for angle relationships. So the way that we look at this can be a little bit confusing sometimes, but in general, outside of our lines, so this black region and this black region, so outside of those 2 lines that are being crossed by the transversal, so not outside of the transversal, but outside of those 2 lines that are running next to each other, we call this region in black, this is our exterior. And you can probably guess the flip side of that would be the interior. So if we're looking at the region in the middle, and we'll see if we can get a good color for this. It'd probably help if I highlighted. Region in the middle here in green. So this is our interior. So anything highlighted in black is outside, exterior. Anything highlighted in green is inside or interior. So if we're looking for exterior angles, just in general exterior angles, it'd be any angle, and we'll circle them in black, that is on the outside. So angle 1 is an exterior angle, angle 2 is an exterior angle, and I'll have you just pause for a moment here and tell me what are the other 2? What are the other 2 angles that are on the outside? So they are angle 7, and they're also angle 8. So interior angles, I'll have you pause and fill these in here. What are some interior angles? So interior angles are the ones that are highlighted in green. They're on the inside, so we'd have things like angle 3, angle 4. Both of those are on the inside. Also angle 5, angle 6 on the inside as well. So anything in green, interior, anything in black is on the exterior. The second concept that we're going to take a look at here, I need to clean up this work just a little bit. We'll start fresh. Consecutive versus alternate. So if we're looking here just at our transversal, so that's the line that goes across. So the transversal separates this out into, we'll call it side 1 and side 2. And again, they're basically cut off here by our nice transversal. So it splits the angles into being on one side, the left or the right, basically side 1 or side 2. So what happens with this is we call something consecutive if it's on the same side. So if you want to make a note of that, consecutive means same side. So they're both on side 1 or they're both on side 2. And we've already labeled and we've already talked about interior and exterior angles. So we know that the interior are the ones that are in the green here. The exterior are the ones that are on the outside. We had highlighted those in black before. So if we're looking for consecutive or same side interior angles, we would have to look at pairs. So here, our interior angles are 4 and 5, and they're both on side 1. So angle 4 and angle 5 are both on the same side, and they're on the interior. So that makes them consecutive interior angles. So using 2 adjectives for them. So I'll have you tell me, what are the other 2 consecutive interior angles? So you can go ahead and answer that one now. So the other 2, again, on the same side, on side 2 this time, and on the interior are 3 and 6. So those are the ones we're looking for there. So let's actually skip ahead to our alternate questions here. So go on to part D. So alternate is just the exact opposite of consecutive. It means that we are on opposite sides. So we have to be completely on a different side of the line. So side 1 and side 2, those don't work. We'd have to be basically one is on side 1, one is on side 2. No repeated sides here. So alternate, so opposite side and exterior angle. So we are looking for things that are on the opposite side of the line and also on the exterior. One thing to note about these is they can't be next to each other, so not adjacent. I don't know what symbol that just made there. That's weird. So not adjacent. So for this, we'll see angle 1 is an exterior angle, and it's on side 1. So we're going to need an exterior angle that is also on side 2 this time. So it's either going to be 2 or 7. And we have to pick the one that's not directly next to, that's not adjacent to 1. So that leaves us with angle 7. So 1 and 7, they're on opposite sides, and they are on the exterior. So the only ones we haven't used now, we have angle 2 and angle 8. So again, angle 2 is on side 1, or sorry, on side 2, and angle 8 is on side 1, so they're on different sides, and they are both exterior. So they're both on that, what we had that region shaded in black before. So pretty similar concept here for alternate interior angles. The only difference here is that instead of being exterior, they are on that green space in the middle, they're in the inside. So alternate interior, we'll just start off with angle 3. So angle 3, and we can't pick the one that's right next to it, so we can't pick 4. So it's either going to be 5 or it's going to be 6. Well, 6 is also on side 2, so it's not an alternate angle, so that means angle 5 is on side 1, so it's on a different side than angle 3, and it's still on the inside, so we're going with angle 5. So that just leaves the 2 that we haven't used yet. So we have angle 4 is on side 1, and angle 6 is on side 2. They're both on the interior, so they meet being on opposite sides. So that's the alternate part. The interior part is also met because they're in that inside region that we had in shading green. So those are alternate interior angles. All right, our last set here is corresponding angles. So bringing us back to our clean template here. And the funny thing about these is that actually all this interior, exterior, all that stuff doesn't matter at all. These are my personal favorite ones because I don't know why, it just always kind of clicked for me here with corresponding. So the way that we think about these is we take a group. So we'll have group 1 and group 2. And think about these like the small groups that we work in class. And what we're looking for is who is in the same seat, who is in the same role within our groups. So if we start off with angle 1, the person that is in angle 1's position is in the top left corner of their group. So what we have to do is we say, okay, our corresponding angle, we go down to group 2 and we look for who is the person that's in the top left corner of group 2. Well, top left, that's 5. So 1 and 5 are a match. They're in the same seat, they're just in different groups. And that's how corresponding angles work. So we can keep going. We go to person in seat angle 2. So seat angle 2 is top right corner. Well, we'll go down to group 2. Who's in the top right corner there? Who's in that same spot? It's person number 6. So angle number 6. So we'll draw different shapes to differentiate these here. But again, we're just looking for the matches. So who's in that same spot? So we'll keep going. Angle 3 is bottom right in group 1. So bottom right in group 2 is angle 7. So again, same seat, different group, and that just leaves us with the leftovers. Angle 4 is bottom left. Angle 8 is also bottom left. So those are the different types of angles that you're going to see today. And a lot of the practice questions just involve identifying what those angles are. So if you do a good job of labeling interior and exterior, if you do a good job of labeling side 1 and side 2, and if you do a good job of identifying positions in group work, so group 1 and group 2 have those little clusters of angles, you'll be in good shape to do really well on those questions. As always, thanks for watching. Hope this video helped, and you are ready to start those